Sit there. Just make it look good.
Well, good evening, everybody. It's a very long time since I've given a lecture at Manly-Warringah Radio Society, isn't it? Anyway, I thought I'd come along tonight and talk about my other hobby. That's my new toy. Some of you saw it last week, but we'll get into it. What I'm going to look at tonight is... why doesn't this thing go on?
Obviously computers is not your hobby.
Can we start the camera?
The camera's on? You've probably seen photographs of telescopes over the years, and there are just so many different types, and what they've tried to do is compact them. The very early telescopes were enormously long because they were just a single tube called a refractor. A refractor has a lens in the front, either a diagonal or no diagonal, and then the eyepiece in the side. Come in, sit down.
There's room at the front. It's free. It's free at the front.
Now this small telescope, this is my target shooting spotting scope, is an example of a refractor. It has a single lens in the front, the objective lens. Now this one actually has some prisms because it folds back on itself and then comes out at 45 degrees. But an astronomical refractor has a 45 degree diagonal here, and the eyepiece sits in there. And all telescopes work on the same principle, that the first lens is ground with a certain shape to give a focus at a particular point, and this one would just have a single lens here, and its focal point will be just there, and then this eyepiece will have its focal point at the same place, and it's the ratio of those two focal lengths that give you the magnification. Now if we look at the actual light path of the refractor, light comes in through the objective lens, bounces off the mirror and comes up into the eyepiece, up into your eye, and you just adjust the position of the eyepiece to get the focus back onto your eye and back in focus. Now the second type that they made was what's called a Newtonian reflector, and that's that one over there. This particular telescope has a mirror in the back here. The front is just opened. You can actually see right down the tube. Just in the inside here is a diagonal mirror that catches the light coming back up this way and shines it out through here into the eyepiece on the side. So this is the front of the tube. Light comes in, hits the mirror, bounces back onto the diagonal, and then comes out the side. There's the focal point just there, and this is the eyepiece that's focusing onto that same place. And this comes up into your eye for viewing. Now the third type, which is this one here. There's dozens more, but I'm concentrating on the main three. This one's what's called a Schmidt-Cassegrain. This one folds a second time. Now if we just go to the light path, the light comes in the front, hits the main mirror, bounces forward onto a secondary mirror, bounces back through a hole in the primary mirror, hits the diagonal and focuses just there, and then the eyepiece looks on that and the light comes out for you to observe. Now there's some subtleties that they've put into this. This plate here that holds the secondary mirror is now actually a lens. Mine has a coma corrector, and the original Schmidt-Cassegrains had a bit of a problem of a furriness around the image. But with the newer ones, they've put this plate in, and it's a coma corrector, and it makes the images just focus so sharp. They're just absolutely brilliant. Tonight will be a good night to have a look because we don't have the moon, I'm going to have a look at Saturn and the rings. Now, all telescopes are sat on a mount somehow. This one sits on the ground and doesn't really move other than by brute force. But the typical mount was what's called an alt-azimuth mount, and that's an alt-azimuth mount. It rotates around in azimuth and it tips up and down to give you the altitude or the elevation of the tube. So this one turns here and tips there on that axis. These have the advantage that they're very simple. That one is computer driven, that one's computer driven. The disadvantage is that as they only tilt in a certain direction, they don't accurately track the sky as the Earth rotates. But when they're computer driven, the computer just takes care of that. It knows how much to turn it, how much to tip it, and it will track as well as that one. Now, that is the absolute simplest homemade alt-azimuth mount. It rotates around here on some wheels or bearings or something, and this wheel just rolls around in this groove. Very simple, and yeah, they do work. You can look at the sky, and they're great fun to use. Come in and sit down. You need more chairs.
We do.
There's more chair at the front.
There's 2 chairs up the front.
Great.
Now, I had to include my new toy, didn't I? And this is the Meade LX200, which is an alt-azimuth mount. Motor driven, computerized, 5 computers.
Have you rewritten the software yet, though?
Don't get me started on software. Now, the second type of mount that they made is that one there, and this one is called an equatorial mount. The equatorial mount rotates the telescope tube on a line that is angled at the same angle as our latitude. So the angle here is set up so that is pointing at the South Galactic Pole. Now, unfortunately, we don't have a nice bright star there like they do in the Northern Hemisphere. This is a Northern Hemisphere telescope, and there's a place here to put a spotting scope through the barrel, and you look up through here, and you align that on Polaris up in the Northern Hemisphere, and that just takes care of everything. Now, when this rotates, it'll actually follow a star across the sky exactly as the Earth rotates, and you don't need to track in that direction, whereas the alt-azimuth telescope when you're following an object, it's got to rotate in both directions like that, so it has to turn and tilt at the same time, and as it goes up over the top, it'll go to there and then start coming back down. So that's a good job for a computer. It's too hard to track with that manually. Now, all the images on the net are Northern Hemisphere. Let me go to the next one. I think this one is clearer as to why we're doing what we're doing. Here's the rotational axis of the Earth, and we're sitting here at some point. That axis points to Polaris, the North Galactic Pole. And what you want to do is you want to have that axis of your telescope pointing at exactly the same place. That displacement there is absolutely minimal given the distance to the star that you're looking at. When the telescope rotates around, as the stars turn overhead, or the Earth rotates underneath it, this axis just rotates and the telescope will just track across following the sky. And that means that once you've set up the telescope and you're locked onto some object you want to look at for a while, the telescope will just track with it and it'll remain in the eyepiece. If you're looking at something like one of the planets and on high magnification, the object will drift out the side of the eyepiece in sort of 5 or 10 seconds. So by the time I've set it up and said, have a look at that, you look and it's gone. But I'll put the tracking on both of them tonight, and you'll actually see that the object will stay in the eyepiece. That one there, it'll just stay in it for the whole night. It'll go across and the object will set and it'll still be there in the eyepiece. Now that's just demonstrating how everything in the sky, these are star trails, and you get this type of image by sitting your camera still for possibly 2 hours for that one. 15 degrees an hour they'll scan, and everything rotates around good old Polaris in the Northern Hemisphere. And you can do that if you've got a camera that you can open the lens, just sit it on the front fence pointing up the sky, open the lens and leave it there for an hour and come back and you'll have a photo not unlike that one. Now, some of our favourite little objects to have a look at. We do have our sun. Our sun is magnificent to look at. There's sunspots, there's flares and filaments. You can't see them on the main part of the disc, but you certainly can see them around the side. And you'll just look and you'll just catch a big filament just hanging out the side. And when you look at the size of them, the filaments are 1,000 Earths across. It's just staggering distances. So everybody knows the planets and their order, and Pluto, I still call it a planet.
I'm glad you included it. I still call it a planet.
So they're great to have a look at. I just grabbed a few images. Okay, Mercury. A lot of these are taken with spacecraft that have travelled in much closer, because Mercury is one of these things that you don't ever get to see it like that. It's a fair way away, it's very small, and it's unbelievably bright when you look at it through a telescope, and all it is just this bright blob. It does have quite a bit of detail when photographs from a spacecraft. Pretty much the same with Venus. Not a great deal of detail in Venus. You'll see Venus, very high in the sky, at least once a year. God, this computer's slow. Good old Earth.
Can we get a shot of that? Can we have a look at that when we're out there?
Oh, yes.
You want to see that one? Okay.
You can, but the grass will be in the way.
I found very rarely do you ever see a photograph of the Earth with other than the United States in the picture. I found this one with Australia, so I decided to chuck it in. Now Mars. Mars is directly overhead at the moment. It's a little bit past opposition, so it's deteriorating in its viewing quality. Best viewing is when the planet's directly overhead at midnight, because you're looking up to the least amount of atmosphere of the object. We'll point the telescope up at Mars. Now, I think these are not taken from Earth. These would be taken with Hubble or something like that to see the polar caps in that much detail. But tonight you'll see one of the polar caps as a white patch, not unlike that. Now, Jupiter. I love Jupiter. I've spent hours looking at Jupiter. I've never seen the red spot. I don't know. There's predictions of when it's going to be visible to us, but I've never actually seen it. Across there and just there are two bands. When you look at it with a telescope from Earth, they appear as black lines. And what they are is it's tear marks in the atmosphere. The polar regions and the central region, the atmosphere moves at a different rate because the planet is so big and spinning so fast. There's these tear lines in the atmosphere, and all of this here is turbulence coming off the side of the tear marks, and so is the big red spot. That's a storm that's been raging since we've been able to observe it. It's been there. It is shrinking. I saw somebody sent me a link to an article, and they say it's shrinking. And whether it's going to continue to shrink, I don't know. But when you put it in perspective, Earth's about that big. Fits inside the red spot, quite comfortably. Yeah, it's a giant planet. Just a different view of the red spot.
What is the red spot? Water?
No, it's a storm in the atmosphere. It's in the clouds.
Oh, sorry,
Yeah, it's just part of the cloud build-up.
Is Jupiter a gaseous planet? Full of gas?
I don't know. Yeah, it has an atmosphere, not a breathable atmosphere.
It's a gas giant. No solid land in it.
No land.
Not that we know of.
Anyway, this one I don't know. I think it's just taken with a different coloured filter. Could be infrared or something, where the spot is very dramatic. Okay, just another one. Moving right along. Saturn, my second favourite planet. You can definitely see this division, the Cassini division, in a small telescope. You don't often get to see the shadow of its planet on its rings itself. I don't know where this would be taken from. Could be from outer space. But we'll have a really good look at this tonight. So we'll crank the magnification up to maximum and I'll let you have a look. Now, Uranus. I always thought that it was so far away that you couldn't see it, but in the right skies, apparently Uranus is actually naked eye visible. So, because of its darker colour, it is hard to see, but you don't need a big telescope to see it. Unfortunately, it's not in the sky at the moment. Next time it comes round, I'll be having a very good look with the telescope.
How
It
far
has
is it away?
rings too, does it?
Yeah, and they are at a funny angle to its orbit.
How far is it away?
I have no idea. A very long way.
A couple of weeks in your car.
Big truck.
Just past the shop.
No, your 6,000 kilometres a week is definitely not going to get you even close. Neptune, these photos would all be taken from either spacecraft or Hubble.
And they're racing.
Good old Pluto. I had to leave it in there. Now,
Yeah.
It's bigger than Mercury, isn't
it's bigger than Mercury. Yeah, but it's just so far away.
Is that a planet next to it?
I'm not sure what that is down the bottom there.
it? It's
It could be a moon. Yeah, it does sort of look like it's probably one of its moons or something. Now, I'm just going to, that's the planets. Quite a few of them are visible with the naked eye. most are visible with a telescope. One of my favourite pastimes is watching the shadows of Jupiter's moons actually passing across Jupiter. Now, there's a shadow. When Jupiter's at opposite overhead at midnight, the moons will come up to the disk as a dot, and then as they disappear very shortly afterwards, a shadow appears like that on the planet. When it's moved past opposition, you'll actually see the moon will disappear. Last time I was looking, about an hour later, the shadow appeared, came across, the moon reappeared, and then the shadow disappeared across the surface. And there's 4 very bright, very close moons, and the closest one goes around in 1.7 days. So it's very close, moving very fast, because this is a very big planet. And it casts a shadow every time it goes across. It eclipses it. And you can watch them, and it's great to actually sit there and just watch it over half an hour and watch the shadow or watch the moon move. There's very few things in the sky that you can actually see move. You can see the moon move, as we saw last week going in front of Saturn, but the moons of Jupiter are the other thing that you can actually see move. Now, there was a very rare event just recently. Now, this is, I'm not sure what sort of filters they use to take this, but it shows a triple shadow and two of the moons actually in the photo. You normally can't see the moons in front of the disk, but they've done something with the way they've taken this photo. It's very rare to have a triple shadow that occurs during night time anywhere and visible. There was one visible from Sydney this year, and with all that rain, I never got to see it. So we go from observing things that are really close to observing things that are way, way away. Now, this is called the Horsehead Nebula, obviously because of the shape of a horsehead. There's a combination of glowing gases, the red colours. That's gases in space that are being excited by radiation from stars, and it's glowing a colour. Now the dark part of it is dark matter, dark cloud, dark gas that's just preventing the lighter gas that's being illuminated from shining through. Now this one's called the Ring Nebula. Most of these are photographs taken with very, very big telescopes. You can see most of these objects, and you can get some sort of a photograph of them. Eagle Nebula. Again, just gases being excited by new stars. I hope I've got these names right. I grabbed all these pictures and then I was using them for something else, and then I thought I'd better go back and find out what they are and write them down.
Okay, so we won't know the difference.
Well, it's on video. Well,
that's my opening. Okay, this one's great, the Orion Nebula. Now, this is in the middle of the belt of Orion, and these stars here are quite visible, and the the nebula itself is naked eye visible. You look up at Orion, and the handle of the saucepan, I think, is the way we look at it. And you can actually see it. You just look up there and it's just this fuzzy patch. You don't need a massive great telescope to see it. When you do use a big telescope, it becomes very bright. Not red, it'll be just a whitey, washed out colour. But it really is magnificent to look at. I like looking at things through a telescope that you can actually see, that are what they call naked eye visible. Just a slightly lower powered view of the Horsehead Nebula. Orion Nebula with different coloured filters.
Now that Orion is spelt differently, is it the same one?
Proofreading.
Oh well. Good try.
Now, this is a magnificent group of stars called the Jewel Box, and if you look at it, if that's the box, that's the lid of the box, and that's a ruby sitting in the jewel box. Now this group of stars is located towards the pointers of the Southern Cross. So you've got the Southern Cross, the pointers, the star closest to the pointers. It's just next to there. We'll point the telescope at it and you can have a look at it for real. It is magnificent. That's the same area of the sky, just a little bit lower magnification.
Well, if I bought, say, $100 telescope, I wouldn't be able to see that, would I?
Look, you can see it in binoculars.
Really?
It's all a matter of how bright it is and how much detail.
Depends how well you want to see it, yeah.
Yeah.
It also depends on the backlight scatter of where you are. Around Sydney here, you lose too much as you go out. There are some places where out in the middle of Australia or out at sea where you get far better vision of stars.
Yeah, that's what I do. I'm normally up north.
But when you look at it from the city, you won't see all the tiny little stars. You'll see just the primary stars and the red supergiant in the middle. Now this is another magnificent object to look at, Omega Centauri. Omega Centauri is another object that's naked eye visible, and we'll go out. We'll have a look at it. It's right up there right now. If you get the 2 pointers to the Southern Cross, the top pointer, the one closest to the Southern Cross, you go out at an angle to a star and just keep going the same distance in the same direction, and there's Omega Centauri. And if you look up and look at it, we'll probably see it naked eye visible tonight, as long as we get away from the light outside there. It just looks like a fuzzy patch in the sky, and through the telescope it doesn't quite look like that. This is taken with a very big telescope. Now we're into objects that I can't even photograph from the ground. They're probably taken with Hubble or one of those. This one, it's just a galaxy. I couldn't actually find a name. I found a number on the general catalogue. But there is a nice galaxy that's out there at the moment that is viewable through the telescope. You will actually be able to see it, and we'll point the telescope at it and see if we can find it.
Astronomy.
Hey, on your face?
Well, I don't know. I went searching through all the pictures of galaxies, and I thought I recognised it, but I couldn't find a name or a number. Okay, now, last Wednesday
That
night.
was last Wednesday.
Say again?
That was last Wednesday night.
It was last Wednesday night. Last Wednesday night was one of these rare events that we get to see, and I was going to be somewhere and watching this thing happen if it wasn't cloudy. And it was meeting night, so I thought, oh well, I'll come up here and I'll sit outside and you come inside and have your meeting. But what we're looking at here is, that's the moon, so you can imagine how big the moon was. And Saturn and his rings.
Wow.
Now, Saturn does look a bit washed out, and that's basically this camera that I used was a little point and shoot 15-year-old digital camera. You know, it really is not very good. But the photos came out, yeah, remarkably well.
So was it that at the telescope eyepiece or at the, holding the camera at the Saturn?
No, that's with the camera mounted on the back of the eyepiece, and the eyepiece cranked up to maximum magnification.
So I went home last week, Phil, after talking to you out there, and I got with my camera, and I got that photo with my camera.
How big a lens on the camera?
1200mm. Well, it's a digital with the equivalent of a 1200mm, 200 times magnification.
Yeah, well that's 200 times magnification.
Yeah.
And you don't need a big lens,
Yeah.
big diameter, you need magnification.
Yeah,
to
yeah,
that
it's
photo.
200. And I put it on my monitor and I couldn't see the rings, but on my wife's iPad I could. So it was that close to not getting the rings, but you can see it on a good, with a monitor with a lot of resolution, so I was able to just separate the rings.
Incredible.
Well, anyway, what happened was I was tracking Saturn with the telescope. So the telescope's locked onto Saturn, and the moon came in and covered it. So what I'll do is I'll just go through this series of photos. See, it's going to be fairly slow loading.
It's like a dodgy gift. Yeah, it's going to crash into us. Might just like.
This was probably about half an hour sequence.
Wow. Say goodbye to Saturn.
Oh, crashed.
No, it didn't crash, it came out the other side. Which I didn't take any photos of, I should have.
Must be made of cheese.
Halfway. That bit from first touch to last scene was about 10 minutes. That's it. Gone.